Hi guys, here's another quick test on or demonstration on this Geiger Counter project I'm working on. So we've got our test source right there on top of the test tube. We're still running the same Mark 1 circuit that's really awful, but it's prototype, so it's proving the point. We have the Arduino here, and we have the newly configured LCD instead of the OLED that we had a minute ago. Here's the OLED that I took off. The reason I took this OLED off is by the time I configured it and allowed it to use enough memory to map the actual display, it took about 900 bytes or something like that, and that left me with only about 200 bytes worth of memory for the actual program. So it became pretty much useless. So I've put this in place, I've installed the LCD library, set all that lot up. Sure, it's taken a little bit more program space, but I've sort of got my key of memory back again. So it's proving to be pretty good. I've changed the way I'm designating these codes, just out of testing more than anything else. So we've got counts per 5 seconds here. So that's a continuous average of the recent 5 seconds. Looks like the code's just crashed actually. Let me just reset that. The display wasn't working. The chip was still going, but the display had crashed. Yeah, it looks like I might have... oh, look what happened. Look what happened. Let me get some light down there. A wire's come off. It's not going to work very well if you take the data pin off while you're moving things. Let's just reset that again. So it calibrates the HT, it sweeps the PWM, which generates different voltages as the PWM sweeps, and it eventually settles on what it thinks is a reasonable voltage for the driver. You'll see the voltage is varying a lot here, so it's 360, and in a moment you'll see it's a lot higher. The reason it varies is every time there's a pulse from the tube, it takes the power supply down quite a chunk because of the 10 meg resistor that's in place. That's pretty much normal. There's no real way around that. I might increase the HT threshold a bit and give it a little bit more high voltage just to see how that goes. Anyway, back to what I was saying. So it's CP5S, counts per 5 seconds. This is the average counts over the last 5 seconds. Counts per 1 minute, CP1M, is the average counts for the last entire minute. And max C is the highest count ever detected during 1 minute. Over here we've got the voltage display, 374 volts, and it flickers and changes over to the amount of minutes that the device has been running. So counts per 5 seconds is always there. That's the most important figure. That's right now, that's what you're being hit by. And max counts is the maximum we've had in any 1 minute. Counts per 1 minute is the average for the last minute. So if I take my test sample away from the tube, counts per 5 seconds will drop dramatically very quickly because, again, the test sample isn't against the tube, so it'll go back down to the ambient or the background. Counts per 1 minute will slowly descend. So it's 456, 448, 406. So you'll see that's dropping down on a minute average. And you'll see the max count is going to stay at the same. So max count is 665. That's the highest it read at any point. So I think this display is working better. It's going to work a lot better as far as program space goes. But I think this very early Mark 1 prototype is actually, although still hideously ugly, is now pretty much a functional unit. I think this is going to work well. Thanks for watching. Any comments? Please feel free to ask. I'd be happy to answer any questions I possibly can.